So example 2 takes us to a picture involving what we just saw in the example 1, with a right triangle PQR, right angle at Q, altitude QS drawn to the hypotenuse PR, and that means that this triangle is similar to this triangle, similar to the whole big triangle. And again, it matters what is similar to what. So what I know is that if I mark this as 1 and this is 2, that this is 1 and this is 2. So as far as identifying the right triangles that are similar in the correct order to show what sides are proportional, it's very important that we know which sides are corresponding to each other, right? So we need to make sure that we're focusing on the order in which we write our congruence statement, or our similarity statement. So all 3 triangles, again, we know are similar to one another. I'm going to start with the main triangle PQR. Triangle PQR is similar. If I take a look at this triangle here, P has 1 mark, Q is the right angle, R has 2 marks. So if I go 1 mark, right angle, 2 marks on this one, it's PSQ. If I go from 1 mark, right angle, to 2 marks on the other one, it's going to be QSR. The question's asking us for the length of QS, so I'm just going to put an X on that. Put an X there. And one piece of advice on these problems, it's helpful sometimes we do separate the triangles. So if you draw them, all 3 triangles out, marking what you know on them. So if, for example, I redraw PQR on my paper, don't have to draw it to scale, just make sure it's marked up properly. Right angle's up here, 2 marks on this angle, 1 mark on that angle. This is 20, this is 15. And SR is 9. It doesn't tell me how long PR is, so I don't really know how long that piece is, so that's not really helpful. So I'm not going to put the 9 on it. And then if I look at PQS, P is 1 mark, Q is 2 marks, S is the right angle, this is Q, this is S, this is P. 20 is here, and that's X. Okay. I'm not going to draw the other one yet. All right, take a look at what I know here. So this side corresponds to, I'm going to put 2 marks on it. This side corresponds to this side, and this side corresponds to this side, and this side corresponds to this side. Okay, with the setup that I have there, do I have enough information to figure out how big X is based on what I'm looking at there? If I set up a proportion, what would go, if I put 20 on top, what would be on the bottom of this one? So if I put 20 on top, which one of these sides would go on the bottom? X. But we're already using X over here, so maybe this is Y. All right, so we did that. So 20 over Y, oops, 20 over Y. And then X would go over 15, right? And this is 20, and maybe this is Z, right? Can we use that to figure anything out? We've got 3 numbers in the thing, right? But does any one of those proportions, any pair of those fractions allow us to figure out how big anything is? If I took these 2 here, I'm going to get XY is equal to 300. That tell me what X equals, what Y equals? No. All right. So again, looking at this, since the corresponding sides, this doesn't match up to anything we know, it's not going to help us find it. So that's all well and good, but this QSR might be more helpful to us. So if I draw a QSR over here, Q here, S here, over here, this is what we don't know, X. SR is 9 and QR is 15. So looking at the main triangle, 15 is opposite the angle with 1 arc, and that's angle Q, right? Q has 1, R has 2, S is the right angle. So 1 arc opposite 15, 1 arc opposite 9. Those sides should correspond to one another. And 2 marks opposite R, 2 marks like that. So R, 2 marks goes here, and then 3 marks is the hypotenuse. So now if we are considering corresponding pieces here, let me just highlight these. 15 matches up to 9. 20 matches up to to X, and Y matches up to 15. Okay, we're trying to find QS, the yellow one, so that makes sense. We want to use that. So if I were to put X and 9, the measures from QSR on top, the side matching QS in this triangle would be 20 in the big triangle. And put 9 SR on top of this one, the side matching up to SR is QR, which is 15. And now we have a workable proportion. We have one unknown. Again, with proportions, we're legally allowed to reduce if we wish. We don't have to. We can work with them as is. But I can reduce vertically or horizontally in a proportion. I'm looking at the 20 and 15 at least. 20 divided by 5 is 4. 15 divided by 5 is 3. And again, that's a legal reduction in proportion. Fraction 1 equals fraction 2. Reduce across the bottom, reduce across the top, or reduce up and down. I could also say, hey, 3 and 9 both divide by 3. So this proportion is equivalent to the original proportion. Both of these reducing by 3 down to 1 and 3 is also legal, so x over 4 equals 3 over 1. And all this reductions is not required, but anytime I can avoid using a calculator, it makes my life better. So by reducing the fractions or the proportions, I've got a much easier multiplication happening. X times 1 is x, 4 times 3 is 12. So x should equal 12, that's the length of QS. So QS equals 12 would be the best answer to that problem. But again, with proportions, make sure that you have 3 out of the 4 numbers within the equation. So like here's, looking at this right here, we have too many letters in there. We can only have 1 letter in a good proportion. So once you have to start comparing one side to some unknown to make some other side to some other unknown, that's no good. You have to get more numbers. So 3 total numbers required to find 1 missing thing in a proportion.